Okay, so just to be clear on the final step for problem 68, in that last video we found that we wound up with an equation like this. This is the distance between the ball and Matthew as a function of t, and this is the right hand side of the equation. So again, very complicated formula when you add in all the numbers, but when you graph using your graphing calculator, I hope your graphing calculator can handle a complex formula. You want to plot d here on the y-axis and t on the x-axis. And if you think about what's going to happen, at time 0, the ball starts out pretty far away. Tony is, whatever, 90 feet away from the Ferris wheel, etc., etc. So the ball starts out pretty far away at time 0, and as time goes on, it gets closer and closer, so d goes down. And then at some point, the ball and Matthew are at roughly the same position x, and y is going to be a certain value, for example. But in any case, after that period of time, the distance is going to increase again. And then we don't know exactly what happens in the long run. Eventually the ball will fall to the ground and stop, and then you can imagine the rest. But the point is, when you graph the initial portion of this function, it's going to have something like this as a shape. And I think what you're going to do is just sort of eyeball the low point, that's the minimum, and find out what t is, and find out approximately what d is. Again, just using the eyeball method. Okay, hope that's clear.